Hello everyone, welcome to another video of my channel. Today we'll be discussing with a very simple and straightforward problem named maximum depth of binary tree. Its LeetCode number is 104. So let's get started. As you can see, the problem says given the root of a binary tree, return its maximum depth. We know about binary tree that binary tree is a tree where each node can have at most 2 child nodes. That's it. So a binary tree's maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. That means how far you can go from the root node to the farthest, I can say, leaf node. So if we have a look at this tree, from 3, this node, root node 2, we can go to this node having value 9. So here we travel 2 nodes. Now if we choose the right side, from 3 to we can go to 20 and then 15, or from 20 we can go to 7. In this both case we are traversing 3 nodes. So here the maximum traversing path is this 320 15 or 320 7. So the maximum depth of this given binary tree is 3. Now let's try to solve this problem. One thing to remember is this: whenever we get any tree related problem, most of the time we will be solving it with either BFS or DFS. And most of the cases we'll be seeing that we are solving this problem using DFS. By DFS we know that it's a kind of recursive approach. Whenever we are not getting our base case, we are calling the recursive function, and when we get the base case, we simply keep returning the values. So in this problem we will apply the same approach. So here in this case our base case will be, say there is no node in the tree. So if there is no node, that means the root node is null, then we return 0. And the recursive case, which is a bit difficult to find out, will be adding 1 and keep finding the depth of that node. So let's try to describe this line a bit more. Here you can see a binary tree, and this is the common structure of a single node. Here a node can contain value, and it contains 2 pointer, you can say, or 2 reference to its left and right children. So as we were talking about the recursive case, so at first we'll start from the root. Since the root is not null, that means we are confirmed that there is a single node, at least there is one node. So the depth of the binary tree will at least be 1. So we will keep this 1 in consideration and in our calculation. Our recursive approach in here will be 1 plus, say our function name is h of 2. By h of 2 I mean the left child of this root node, and h of 3. By h of 2 and h of 3 we are trying to find out the height at that height of the subtree, or the tree starting at that particular node. Now as you can see, we got left child and right child, so we got a left subtree and right subtree. We will consider that length having the maximum value between these two. That's why we have taken the max. Now as we can see, the recursive approach has called the function again. We need to call the function again. So here we will go to this node. In this node we can see that this node is not null, so we'll similarly call the recursive function again. Here it will be 1 plus maximum of, find the height of this 4 node or this 5 node. Similarly, we will be keep going like this until we reach the leaf nodes. Once we have come to this 7 node, this is a leaf node, and we can see that this leaf node neither has a left child nor a right child. So the recursive approach here will look something like this. And since in this case, as we have found the base case, this h null will return 0 and this h null will also return 0, and the maximum between 0 and 0 is 0. Since we got our base case here, we will be returning the value to the upper child. That means this 7 will return 1. This will return 1 to this upper child. So the value of h7 is 1. Now we got to go the h8, that means this node. Here we can see that this node has a left child but no right child. So here the equation will be h9 will be called, but we know what will happen here. 1 plus similar this will happen similar to this node 7. In fact, this will have similar thing will happen for all the leaf nodes. So I'm not calling it again. Here we know that this h9 will return 1 and h null will return 0. The maximum bit here is 1 and 1 plus 1 2. That means this h8 will return 2. From this maximum of h7 and h8 we get 2. That means 1 plus 2 will return 3. This h4 will return 3. Now we need to call the h5 method. The 5, node 5 being a leaf node, it will also return 1 plus the left and right child being null, 1 plus 0. That means this h5 will return 1. h2 function, this will return what? 1 plus 3, that means 4. So we got 4 for this h2. Now it's time to call the method h3. As we can see that node 3 doesn't have any left child but has a right child, so its equation will be 1 plus maximum of h of null and h of 6. We already know that h of null will return 0 and h of 6, node 6 being a leaf node, it doesn't have any left or right child, so this node 6, h of 6 will simply return 1. This h of 3 will return what? 1 plus maximum between 0 and 1, that is 1. 1 plus 1 2. Finally we got what? 1 plus maximum of h2. h2 means this left subtree which has returned 4, and h3 means this right subtree which has returned 2. So the maximum is 4. That means the maximum depth of this whole binary tree is 1 plus 4, which is 5. And if we have a look at the longest path, you can see that 1 2 4 8 and 9, there are 5 nodes in this longest path, which is the maximum depth for this binary tree. Now if we talk about the running time complexity of this approach, this will be big O of n, since it covers all the nodes of this tree, n being the total number of nodes in this tree, binary tree. Space complexity will be constant because we are not using any external data structure. Now let's try to solve this problem in LeetCode. Here is the problem. This is our approach. At first we have written the base case and this is our recursive case. Now let's submit this problem and see what happens. And yes, we got accepted. That's all for today. I hope you guys have understood the problem and its solution approach. Happy coding.